So this is a rapid-fire lecture on how to laser cut in the same way that Timothy Ferris teaches his 4-hour work week, his 4-hour body. I'd like us to start getting in the habit of doing the 4-hour workshop and learn to become a capable maker in just a few hours. The first thing we need to know when we're talking about laser cutting is what the difference is between a vector and a raster. We'll talk about that. There are a couple of variables with a laser. There's the speed that it moves at, the power that it burns at. You also need to know that the laser makes a little bit of a wide cut. It's not infinitely zero. There's a thickness to the cut. Just like a table saw blade leaves a mark in the wood, so does a laser. You need to design for that. And what materials you can cut. We regularly cut plywood, acrylic, which is a type of plastic. We can cut leather. We can also cut paper, poster board, and cardboard. That's great mock-up material if you just want to do a quick mock-up. We can't cut metal, and we don't cut PVC or vinyl, anything with chlorine in it. Our mentors can tell you what does and doesn't have chlorine or vinyl in it. We can etch glass, but we can't cut it, and we can mark metal, but we can't cut it. We have friends in town who can cut metal with a laser, but we won't be able to do it for just this quick weekend. So what else can you do? Well, try and see. As long as there's no PVC or vinyl or chlorine in it, we're happy to try it out. We've done marshmallows, toast, hot dogs, pumpkin pie, and it's a lot of fun. So the two types of file inputs for laser cutting are a vector or a raster. A vector is a line art. It's a PDF or an SVG or an AutoCAD DWG format, mostly used to cut material by burning cleanly all the way through the material. We can also send a raster file to the laser. That's like a JPEG, a GIF. It's a bitmap. It's a photo. This is used mostly to draw on material by burning it. That's called etching or engraving. So to show the difference between a vector and a raster, if we were to vector across this whole dark image, then the laser would have to travel all the way across it, much like a dot matrix printer. As opposed to vectoring it, the laser just traces the line art that we've created with our vector file. So here we can see what the laser would have to do in order to etch or burn this image into wood or into plastic or lightly onto metal. It'll take a bit of time because the laser has to touch every spot this black square has. But if we're doing a vector, then the laser just travels along the edges of that vector. And you can see in this case, a vector would be much faster than rastering across the entire image. And here, if we were to raster it, this would be how it would appear on the plywood or on the wood. And if we were to vector it, those lines would occur like so. So that's a real brief difference between a vector and a raster. Same thing applies to text. If you have text and the text is fully solid and you're rastering across it, then the laser would have to go across every line of that bitmap or JPEG or what have you. As opposed to if you made a vector outline of the text, then the laser only traces the outline of the characters of the text. So again, this is how it might appear as it's rastering versus vectoring. Now, vectoring isn't always faster than rastering. It mostly is, but if you have a really complicated vector, like something like this, then you can imagine that, in fact, rastering, as slow as it is, having to go over every line of the entire JPEG, it might in fact be faster in this case than rastering every little perimeter. That's a judgment call. You can do some quick math to figure out which is which, but vectoring 90% of the time is going to be faster than rastering. And it's always the way that we cut through stuff. Well, not always, but we'll talk about that in a bit. So in summary, you need a vector file, and that's often a PDF or an SVG or DWG. We take these latter formats, we convert them into a PDF when we load them onto our laser. And these can be made from Adobe Illustrator or from Inkscape, which we like. Inkscape is an open source vector design software program. You can download it for free, learn how to use it for free. I encourage everyone to tinker with it before startup weekend. You can even take a hand drawing, and we can scan that hand drawing and turn it into a vector. These vectors are mostly used to cut through material. And here we have an example of a vector that cut the outline of a piece of wood and then also cut this intricate design within. Really cool. You can also take 2D vector cut pieces of plywood or acrylic or whatever and stack them together to make these 3D shapes. there's a great tool called Slicer, which is an add-on for Fusion 360, which is a free CAD program that will help take 3D shapes and turn them into the 2D shapes you need to laser cut and then assemble. We'll talk about Slicer later. And then if you want to cut out of plastic, here are some nice examples of a laser cut enclosure or box that was made out of probably an acrylic. And you can see it has some tabs already laser cut in place so that you can snap it together and hold it together like that, or even just snap it together while you glue it. There are software programs that will help you take a 3D shape and add these tabs, add finger joints. Makercase.com is a great one. Makecrate.io, I think, is another one. We'll talk about how to do that later. And then you can even cut acrylic and score it. You don't have to cut all the way through the material. You can just essentially cut it a little bit so that you can then bend it. And here someone took essentially a kind of Google Cardboard design that allows you to snap your phone in place and make a virtual reality headset display with a laser cut piece of acrylic that is both cut through and also scored for bending. There are even origami type software programs that can help you do that. And then it's also fun to cut fabric or leather. You can do really intricate designs in fashion like this too. Things that might take too long to cut by hand can suddenly become cost effective when machines do your busy work for you. Now, if you have a raster file, again, that's something like a JPEG or a bitmap. Those are often made from photographs or two-dimensional image designs. Those are mainly used to etch or engrave into material, that is, to burn lightly into it. And you can burn intricate images like this into, for example, this wooden cutting board, or you can take a photograph and you can etch it into wood or plastic. Notice that as you're burning into plywood, the grain of the wood will also have an influence on the contrast. So you can see a bit of the grain of the wood in here. So you have to take that into account if you're trying to do a really intricate, detailed image. Otherwise, you might use something like glass or clear acrylic if you want a really clean, homogeneous substrate so that you don't have the grain of the wood to interfere with your pattern. There's also a way to take aluminum and mark it or anodize it with all sorts of colors, red, white, silver, black in this case. And wherever the laser etches over it, it removes the dye from the anodized surface and leaves a white mark. So you can get very high resolution photos like the samurai on this material. So here we have a little video from this YouTube link here. And I just wanted to show what a laser looks like as it's both cutting or engraving. In this case, it's engraving vector images into this two-dimensional or this little piece of plywood. Fun little steampunk bird. And notice that it's etching the text, it's etching the images. Also notice that these people have cut in advance a clear plastic jig. So this is a little device. Looks like they cut it out of clear acrylic so that they can put these pieces of plywood in here, and that way it probably lines up with the pattern they've already created on their software program, so they don't have to align the image to the piece that they're cutting on every time. So often making jigs like this is a great time saver. I'm going to jump forward a bit here, and shortly they're going to start rastering, and you'll see how quickly these vectors happen, and then here it's rastering, going back and forth, left to right, to color or darken or burn the surface of the interior of those gears to give it a little bit more contrast. So you can see the difference in the speed between vectoring and rastering. And then they put their maker's mark on the back. Really fun. Now this next video, I'm going to record his audio as well. Hopefully you can hear it through my microphone. This is a great example of taking a 2D design from a through the web app that lets you design a box and then fit that box to a laser cuttable pattern.
One of the first things I made when I got access to a laser cutter was a jointed box. It's a simple project and you're going to learn a lot about laser cutters. And we're going to talk about how to make it right the first time, which requires you to know about kerf. All cutting instruments have some amount of kerf, and that's the area cut away by a tool. You're going to see on a table saw, it's going to be really easy to see. And lasers have a kerf too, it's just really, really small. If you don't account for kerf, your tolerances are going to be off and parts aren't going to fit. So I created a test with 3 finger joints and 3 different kerfs. When we set the kerf at 0, and this is assuming no kerf, the box is going to be way too loose. When you make the kerf too large, here we have it at 0.01, the parts are going to be too tight. For this material, which is 5mm plywood, 0.005 as the kerf is what's going to get our best results. So by understanding kerf, you can adjust your joints to be loose or tight. So how can you figure out your kerf? You just need to make some test cuts. I make 5 1-inch squares and circles that are 1 inch long and 1 inch in diameter in my cutting software, and then I cut them. You then just take these and measure them and take down your readings. When you take down these readings, you want to average them out over how many pieces you have, so 5 pieces. And then you want to subtract that from 1, which is your gold standard, the size that we set within our design software. The difference between 1 inch and your measurements is going to be the laser width. If you divide that by 2, you're going to get your kerf. So how do you make a case? Well, I design my cases using parametric software, which means an online software that allows you just to put in measurements and you're going to get a case. First of all, we'll do a 4x4x4 box, and then I will choose finger joints. And then from there, I'm going to go into the extra settings and define my kerf size. Here we're going to use 0.005. I'll then download this file and then cut it out on the material with my laser cutter. So when you figure this all out, you'll be able to do a lot of cool projects. And here are some nice things I've made with jointed boxes. I hope you guys enjoyed this video and found it informative. And if you did, remember to like and subscribe. Thank you. Bye.
Now, I said that mostly vectors are used for cutting, and mostly rasters are using for engraving. But you can also cut with a raster. We call this ablative machining. It's a fancy way of saying you're just burning all the material away. And that's one way to make, for example, these letterpress block letters. So you're machining away all the material except the letter that's going to stay raised up. And that way you can ink it and then press it onto wood. Equally, this is how you make stamps. And there's actually an app in the laser cutter that lets you reverse the image, it bevels the edge for a stamp, so you can make rubber stamps with an image. Again, you're machining with a raster in this case. And equally, you can draw with a vector. You just have to set the power-speed combination so you're not cutting all the way through the material. This is a quick way, for example, to score material if you want to do some origami later, or simply to draw a pattern on a piece of material that you're then going to cut separately. So this is felt for a DIY laser cut clutch bag that the person then cut by hand. You could also do the same thing to mark on metal for bending in sheet metal, or mark on wood for then cutting with a bandsaw. If, for example, you had material that might be too thick to cut on the laser. You could also just laser cut a pattern and then glue that to the piece of material you're going to cut. So next we're going to talk about how to create these vector and raster files using the free program Inkscape. We're going to talk about objects, we're going to talk about line weight for vectors, we're going to talk about fill for an object, and then some text. That'll be in the next video.